Here's a quick timeline of 3D printing. It all started in about 30 years ago. It was invented by Chuck Howell, founder of 3D Systems, one of the largest producers of 3D printers at this time. And then the first printers on the market, they were very expensive and large, and so basically just large companies were able to afford them. Until about 10 years ago, there was a guy named Adrian Boyer from the University of Bath, who used a running patent that ran out to create a low-cost 3D printer that is actually able to produce the parts of new printers. And then the idea of RepRap, or reproductive rapid prototyping, was born. And well, from then on, a lot of new low-end 3D printers came on the market. Until now, there's about 200 printers on the market, and the numbers are still going up. So here you see Gartner's hype cycle. I'm not sure if you're familiar with that. It has basically two phases. The first is when a new technology comes out, there's very high expectations, and the public attention just goes up until it reaches a top, and from then on it goes back down very steeply until, like, after the valley, the attention rises slightly but sustainably. And well, the first, what I was mentioning, the professional 3D printing, which has been out there already for more than 30 years, it's already in the third phase, but the low-end 3D printing is just at the top of expectations or public attendance. I don't know, I guess most of you have heard, for example, in the news that it's possible to even print guns and stuff like that, so it's a very hot topic at the moment. Other technologies that are connected to 3D printing are still in the first phase, for example, Internet of Things or 3D scanners. So the media attention is just increasing at the moment. So what is 3D printing actually? How does it work? Well, 3D printing is the process of making a physical object from, first of all, a three-dimensional digital model, which is then sliced in many very thin slices or layers. And the 3D printer then attaches one layer to another, like usually it's thousands of layers, very thin layers, thinner than human hair usually, and until in the end you get the final object. So what are the advantages over conventional manufacturing methods like casting or other technologies? First and most important advantage is that it's able to produce prototypes very fast, because you have no setup costs basically, or very short setup costs compared to other manufacturing techniques. Then you are able to produce very lightweight parts, because in the manufacturing you can actually put some holes inside the model, or you can determine how sparse or dense the filling, the infill of the object should be, and so it's very weight and cost efficient. If you use, for example, support material, you are able to make very complex shapes, basically any shape you can think of. There are no limitations. And finally, because every part is made basically individually by the printer, it's very cost efficient to customize the parts. So yeah, especially like in the fashion industry, it's possible to make a one-piece product that matches just your needs at a very cost-efficient way. So where is it used? What are typical areas of use? First of all, it's the creative industry. You have engineers, for example, that use this technology for functional and visual prototypes. You have, for example, architects, which use it for producing models of buildings or even landscapes. Designers, which are increasingly using this technology to make all kinds of stuff like home accessories, clothing, jewelry, or other gadgets. And then there are other areas like the medical or in the educational sector. And last but not least, for personal use, there are actually many people that own a 3D printer and use it at home to make just some toys, gadgets, or replacement parts. Okay, so how does a 3D printer actually work? There are different technologies. The most common technology is what fused filament fabrication. It's basically you have plastic wire that is melted and extruded through a nozzle and then attached to a platform layer by layer. And you see here, you can use 3 materials, one build material and one support material. And after the object is completed, you can just remove the support material and you have the final object. You need the support material if you have like overhangs or different difficult complex structures. Otherwise, it's not possible to make these structures. And yeah, the big advantage is the cost, because this is by far the most cost-efficient technology of 3D printing. And the parts are quite rigid, so they are made of plastics. It's yeah, they're quite strong compared to other technologies. On the other hand, it's quite slow and the precision is not the best. Then there's stereolithography. This works. You have the liquid photopolymer, which is cured by a laser beam, and yeah, the platform moves down in this tank of liquid, and so the laser can cure this material layer by layer, and in the end you have again the final object. And here the advantage is speed. It's a very fast technology because yeah, you don't have a print head that has to be moved around. It's just a tiny mirror that controls the laser beam. And the precision is also very, very good. But on the other hand, it's quite costly, because especially this liquid is very expensive. The parts are very unstable, so you can just basically use them for visual prototypes, and if you want to test any functional properties, it's not possible. And furthermore, this is not the safest technology, because the liquid is also quite poisonous or toxic. Then another common technology in 3D printing is selective laser sintering. Again, you have a laser beam, but here you don't use a liquid but powder. This powder is usually a metal powder, which is the big advantage of this technology, because it's the only 3D printing technology so far that can produce metal objects. So yeah, and that's of course why the parts are very strong. But it's again very expensive, and the speed is also, compared to other technologies, not the highest. Finally, there's the liquid binding power technology, which works similar to the previous technology. You again have powder, but this time you don't have a laser beam, but it's a print head with a liquid adhesive adhesion that bonds the particles so that in the end you have an object of, basically powder particles glued together. The big advantage of this technology is that you can also attach colors or ink to the object, because you can just mix it with the adhesion in the printhead. And the precision is quite okay, but it's again very costly, and the parts, the objects that you produce, they are not very strong because they break very easily unless you do some after treatment. So what materials can be printed? First of all, of course, plastics, very common, but you can also print, for example, ceramics or metal, as I already mentioned. But you can also print some very exotic materials, for example, chocolate or cookies, or you can print even houses. So the applications are very diverse of this technology. One very important aspect of 3D printing is the overall printing time, which is not known by many people, because it's not just the print speed that matters, but it's also, for example, the setup time for calibrating the platform, for inserting the material, and for preheating the nozzle and the print bed. And then of course, second is the print time that matters. It depends on the size and resolution of the object, on the speed and acceleration of the print head, and on, for example, switching time between materials. And then there's another point that has to be mentioned, is unexpected delays. For example, when the platform is not completely leveled out, the first layer doesn't stick very well, and so it can happen that during the print it just falls off, and then the printer doesn't notice it and it just keeps on printing, and in the end you have an object that is just halfway printed and the rest is just a big mess. So you have to print it again, which also takes a lot of time. It's waste material, it's costly, so it's a big hassle. Same thing when, for example, there's a material shortage, the nozzle is blocked, the printer doesn't see it, it just keeps on printing, and in the end you have a half-printed model. So you can't use it, you have to print it again. Same thing if you just run out of material without notice. So this is very annoying. And especially with low-end 3D printers, this happens a lot. But if, for example, you go to a printer producer, he would never tell you this. So keep this in mind. In the end, there's the post-processing time for cooling down a printed object before you can remove it. If you print with support structure, you have to remove that as well. And in some cases, you need some after treatments. So, what basically distinguishes our 3D printer? So, if your requirement is low costs, you could, for example, buy one of these devices. It's a MakerBot replicator. It costs about 2,000 euros, but they are already a lot cheaper 3D printers. But nevertheless, you will always have certain drawbacks. It's very reliable. It's difficult to use. It's quite slow, and the build volume is quite limited. So, if you want a large print volume, then you could, for example, buy this printer. It's Leapfrog Creator XL. It has a very big build chamber, but again, it's unreliable, it's difficult to use, and slow. If you want a reliable and easy-to-use printer, you could buy a Stratasys Dimension Elite. This thing costs about 30,000 euros, so it's very expensive, and also the speed is quite low, and the build volume is also rather limited. And here's our printer. It has all the requirements how are we able to do this? Well, we have an excellent cost performance ratio because compared to other 3D printers in the same set of functionalities, the purchase price is very low. For example, compared with this Stratasys device I was just talking about, our printer costs just 3,500 euros about, and also the material cost is much lower than compared to other printers. Yeah, as I said, we have a large build volume of about 30 liters, which is among the top 5% in class. This is done by a very rigid construction, because if you have a large build volume, it is very important that the precision is still guaranteed. Another advantage is that you have a large open-top sliding door for easy access. So most printers have a tiny little door, so you have to kind of climb into it to get out the print objects, and we have a very large door, which is also a very big advantage. It is very convenient to use. It's first of all easy and reliable, and basically you don't have to have any technical skills to operate it. For example, if you buy a RepRap or very inexpensive 3D printer, you will always have to calibrate it yourself. You have to repair it if things break, or if you have to always check if everything's working fine. So this requires some technical skills, and with our printer, we have very many automatic and intelligent systems that do all this, so you don't have to do it. For example, an automatic calibration system, so you don't have to do it yourself, and an intelligent control system which reduces the risk of failing prints, for example, if you have a material shortage or material blockage. And last but not least, the overall printing time compared to other 3D printers is about half. This comes from an innovative printhead that allows, for example, multi-nozzle printing, and also the innovative positioning system, which allows high accelerations of the printhead. Yeah, my colleague Andre can show you some objects which we have printed with our printer. It is first an architectural model, which has about 280 grams. It's made of natural PLA, and the printing time was about 6 to 7 hours. Then there's the juice squeezer, which is about 40 grams of translucent PLA, and a ball bearing, which is quite interesting because it's made of a wood filament, so there's actually wood particles in it, and it's printed in one piece. So the balls and the rest of the bearing is all made in one piece. Well, so that was it so far. If you're interested in our company, there's some information material on the desk, and yeah, if you have any questions, please feel free to ask. Thank you.
If you can you repeat that?
What is the largest object you can
Our printer can so far make objects 300 times 300 times 300 millimeters. So it's about 30 liters. Huge. Yeah, like a cube basically.
You mentioned there are different methods used for 3D printing.
We use the first method, the fused filament fabrication.
Ça c'est cool.
So the melted plastic wire.
C'est cool.
Alright.
Muss noch ein Stück.
Ja, cool. Okay.
Ja, jetzt.
What is the time frame for this finished product?
That's a good question. We are currently working on our third prototype, and no, our fourth prototype. Our third prototype is already finished, and we will soon start our beta test phases. thank you again for your
Vielen Dank für den tollen Vortrag. Ihr könnt jetzt alle Videos auch nachschauen, die jetzt etwas
Jetzt.
verteilt haben. Die werden nächste Woche online gestellt und wir verbreiten die Meldung, die wir so wie haben.
Ja, ja.
Danke.
Danke.